exposing the secrets of electrons. This is gonna blow your mind. In the early 1900s, Robert Milikan designed a clever experiment with tiny oil drops. He sprayed these drops into a chamber and zapped them with X-rays, giving them a charge. By adjusting an electric field, he balanced the gravitational pull and the electric force on these drops. By measuring how fast the drops moved, Milikan calculated the charge on each drop. Guess what? He found that the charges were always multiples of a smallest value. That tiny value was the charge of a single electron. So, thanks to Milikan's brilliant work, we know that each electron carries a charge of 1.6 × 10⁻19 coulombs. Pretty neat, right? Science sure has a way of making the invisible visible. Let's dive a bit deeper into how Milikan's experiment worked. The chamber was filled with a mist of oil drops, and when X-rays hit them, they gained electrons. By carefully adjusting the electric field, Milikan could make the drops hover in place. This allowed him to take precise measurements of their behavior. Through these measurements, he could determine the exact charge on each drop. Milikan's findings were groundbreaking and confirmed the quantized nature of electric charge. Today, this knowledge is fundamental in fields like electronics and quantum physics. Milikan's legacy lives on, reminding us of the power of curiosity and meticulous experimentation. Students around the world continue to learn from his pioneering work. The scientific community owes much to Milikan's dedication and ingenuity. Milikan's experiment was not just about measuring the charge of an electron. It was a meticulous process that required precision and patience. The oil drops were observed through a microscope, and their motion was recorded to determine the effect of the electric field. Milikan adjusted the electric field to counteract the gravitational force, making the drops hover or move at a constant speed. By knowing the strength of the electric field and the mass of the oil drops, he could calculate the force acting on them. The calculations involved determining the balance between the electric force and the gravitational force, leading to the charge on the drops. This experiment was repeated many times to ensure accuracy and reliability of the results. Milikan's results were published and became a cornerstone in the field of atomic physics. Modern laboratories still use principles from Milikan's experiment to study fundamental particles. Students and researchers continue to replicate and build upon Milikan's work, demonstrating its lasting impact. In recognition of his groundbreaking work, Milikan was awarded the Nobel Prize in Physics in 1923. His contributions have paved the way for advancements in various scientific fields, from electronics to quantum mechanics. Milikan's experiment is a staple in physics education, illustrating the quantization of electric charge. Until next time, keep exploring and stay curious.